Once we've done a couple of problems with the constraints given, then we're going to transition into example 2 and other problems like this. We're going to look at word problems, and then we're going to translate those into minimizing or maximizing something with certain constraints. Example 2 does that for us. Example 2 asks us to find the minimum sum of two positive numbers whose product is 400. So if I were to translate this into mathematics, I would say we want to minimize a certain sum. I'll call that sum S. A sum of two positive numbers. We can call those positive numbers anything we want, but I'll choose X and Y. The constraint is that the product of these two numbers is 400. Therefore, X times Y is equal to 400. I will label that as my constraint equation. This looks very, very familiar to a problem we've previously done. We're going to solve it in the same way. I'm going to rewrite the constraint equation. This time, I feel like dividing both sides by X. So I am going to get Y equals 400 divided by X. You could have also divided by Y just as easily. We substitute in the 400 over X for the Y in the equation that I want to minimize. Now that 400 over X can also, or could have also been written as 400 times X to the minus 1. If I want to find where this is minimized among positive numbers, I can take a derivative, find the critical values by setting the derivative equal to 0. The derivative of S is 1 minus 400 X to the negative 2. Or you could have also written that as 1 minus 400 divided by X squared. We set that equal to 0 and solve it. I think this is probably just as easy to solve in the 400 over X squared version. So I'll do it that way. You could have also solved it with the X to the minus 2 version. Subtract 1 from both sides. You would end up with negative 1 is equal to negative 400 divided by X squared. Multiplying both sides by X squared gives us negative X squared equals negative 400. Dividing by negative 1 gives me X squared equals 400. I take a square root of both sides. Now, normally, I would take both the positive square root and the negative square root in a mathematical equation. But in the context of this problem, it says assuming that X and Y are positive. So it's assuming my numbers are positive. Therefore, the only answer that works is 20. Let's go back up and see what that means. Remember, we were going to minimize with this constraint. And now we know that x is 20. If x is 20, my constraint equation forces y to be 20. And then the s would be 20 plus 20, which would be 40. I skipped over one step, but you can do this on your own if you'd like, or you could just trust that we get a minimum. I skipped over the step where I show that this is actually a minimum by calculating the second derivative. So if you wanted to, you can calculate the second derivative, s prime prime equals the 1 goes to 0, and this becomes positive 800 x to the negative 3. If you plug in 20, 800 times 20 to the negative 3 power, it gives you a positive number. And we know that a positive number means that we're concave up at that value of x. And so we have a minimum value. That's how this works. Concave up, therefore, we know we have a minimum value. So the minimum sum is 40 when x equals 20 and y equals 20. And that answers our question. So the minimum sum is going to be 40, and that happens when the positive numbers are both 20. I would like you to pause this video and then try this problem on your own.